Welcome back to like whatever this is, I guess. Still not doing anything of professional quality because I think that's just going to be my bit, is never doing anything of professional quality. Um, it's like, yeah, editing costs a lot of money or takes a lot of my time. So we're not going to do that. I made one professional video for like this weird like VRC showcase thing that I was trying to compete in, and it didn't get in, so my editing must not be that good. Or something. It's not that it wasn't good, it's that they had too many people apply and my just didn't make the cut. I mean, I'm competing with people that probably have like multiple degrees in this type of stuff. But anyways, back into the meat of the material here. I've been working on a series of walking vehicles, if you will, because somebody told me that that walking is not an effective way of movement in StormWorks, and I did not like that. And I also didn't know a lot about programming at the time in which I started building these vehicles, so I did what I knew how to do, which is mechanical design. So I did a lot of research on the web and made legs, crank-driven legs. You can see that down in there is two spinning cranks total, one on either side, that drive the entire leg assembly using some interesting geometry to work. These are my like most perfected leg designs that I've gotten working in StormWorks. There's a secondary design that I was working on prior to this that's way oversized and technically is better in real life, but not for StormWorks. It's the Strombase legs, I think. The other known as Windwalkers. There's a guy who makes like cool big walking contraptions that like walk across beaches and stuff, which are really cool. And that's what these were originally based off of. These ones have way more moving parts, which is not ideal for StormWorks. Moving parts equal bad for vehicle optimization. But it does work. It does move. It's not efficient by any means, and with these legs, it's not that fast. Mainly because of how the crank is set up. There are actually 4 independent cranks that are driving the legs, which causes a lot of fighting between them. I tried to use some level of synchronization for them, and it just did not work. Yeah, so let's go to the ones that are more optimized and actually work for StormWorks here, and let's start dissecting this a little bit. The geometry is a little touchy. You have to get it kind of just right, but there's a lot of different ways that you can like test and tune it. So like you have to have like a mixture of like hard fixed points and moving links here, I guess. And the best way I can really describe how to do it is pull this off the workshop from my workshop page, which will be posted in this video's description and the last video's description. And just play around with it. The control scheme is very simple. It's just a regular tank steering assembly, I guess. Just using like additive and subtractive stuff, which we can break down later in this video for the people that want to stay around and watch that. But he uses that very simplistic system to turn and to go forward and stuff, taking in your WASD inputs, and then converts that to crank-driven rotational energy, and then feeds it into the cranks. I've tried to make this decent enough to like remove. You can kind of just grab the entire assembly plus this wall here and then build your own vehicle using these. Do note that the more legs you have, like if you were to double this assembly and offset it some more, the legs would be more stable. But again, you start running into physics bodies issues, unless if you're running like very high-end hardware, it's going to start to lag. This is not a multiplayer vehicle by any means. It's very unmultiplayer friendly. But this just goes to show that walking is an effective way to move vehicles across StormWorks. No, it does not swim. I'm sure there's a way that you could put like rudders and stuff on here to make it swim, which would be kind of cool, I guess. But yeah, no, I added it to my unethical ways of moving around in StormWorks. So here you go. Now cutting into how the steering system works and just how steering systems for tanks work overall. If you're interested in that, you can stick around. If you're not, then You can hop out of the video now. Thank you for your time. But at this point, I'm going to break into steering systems for tanks. So when you're dealing with the steering system of two like tank tracks or these leg assemblies, because they're very similar to tank tracks and how they operate, you only get forwards or backwards with them. You have to take in your outputs from your helm or wheel or whatever assembly you're using. So WS and A and D. A and D is your steering input, and WS is your forwards and backwards input. So forwards and backwards, it needs to be forwards and backwards all the time. So to do something like this, you're just going to hook it directly up to your drive assembly. We're about to get into some math here in a second. Very simplistic math, but some math nonetheless. So after doing that, it can either move forwards and backwards. Right now it's inverted because of how I've built this entire apparatus, but whatever, not important. But we can't turn. A and D are not factored into how we're dealing with that. So now we need to factor the A and D command in, and that's where these add and subtract blocks happen. You can see, again, I did it the wrong way around. You can fix that just by inverting how it's connected here. But how you always factor it is your W and S command for forwards and backwards is always going to be your A value in the add and subtract blocks here. And then your A and D is always going to be handled by the B value on your add and subtract. And then at that point, this can go directly out to your wheels, your clutches or wheels or whatever you're dealing with, propellers even, depending on how your boat might be configured, or hovercraft or whatever you're building. It's from that point that I started just clamping the number between -1 and 1. This is just an additional step that I took for this vehicle because it can go over 1, because if you're turning to the right and going full speed ahead, you're going to get a value of 2 to your left wheel assembly or tank track assembly. So sometimes you might want to clamp that or divide it by 2 to give you the full range of control. So your inputs don't stack on each other. Actually, you should divide it by 2. That's the smarter method of doing it, looking back at it now. And then the function block that I have here is, again, just vehicle specific, because these things rotate faster the higher the number that you input to them is. And then I inverted it here in the math. So let's build a microcontroller real quick, showcasing that. You'll need, I'm going to take composite data in just to cover how composites work. And then I'm going to have 2 number signals out, because that's all we need. And we can actually stack these values because of the new update where you can stack logic nodes. Thank you, StormWorks development team. And there you go. So now your logic nodes are done. I say they're done, they're not done. I didn't label them. Okay. So seed data is going to come in as composite, and then we're going to send out numeric signals. So let's do some composite read here real quick. Hold down shift to place multiple keys at once. My bad. And then for seat data, because I forget the nodes all the time, I'm just going to step away here for 1 second and look at the composite. So A and D are value 1 and WS are value 2. So let's see here. I'm going to set W and S to value 2 up here, and then this will be A and D down here. So if we remember correctly how we had it configured before, you have an addition here, and you have a subtraction down here, or vice versa. And your W and S is always going to be, as we stated before, your A value. Then your A and D is always going to be your B value. There are more intricate ways of doing this to factor in more inputs and stuff, or your current rotation with the Earth or whatever. You can do all kinds of crazy stuff, but not uber important to me. And then we're just going to send this through a simple function block here. And you could do all this in LuaScript, but I'm not going to LuaScript right now. Just going to keep it simple block logic. And then if I did everything correct, except for make the function, I'm going to actually divide this by 2. This is what I was saying earlier, where you take it and you divide it by 2 to make sure that you only get a value between -1 and 1. And that should work out. Now we'll go to here. We'll just call this I think I spelled that correctly. I hope I did. I'm not the greatest with spelling. And we're just gonna like draw like 2 lines and then like some sort of like differential box in the center. That makes sense to me. And then like it goes out to there and then like just like put a T here, I guess. I don't know. I'm not artistic. I only do like a whole bunch of digital art. Lol. So there it is, the tank steering module. Let's go ahead and save it. Done. And if I did everything correctly, I should be able to take this, put it right here. And now I don't need the clamps anymore, but I still will need the function blocks. Function blocks are important because, like I said before, we're multiplying the value to better account for the drive assembly and make the legs move faster so we can actually move around. If I did it right, okay, so the forwards is still inverted, which is not good, but fixable. Also forgot to run it through the PID. Just fine. And the steering's inverted. Cool. Which means, go back in here. We're just going to do a little bit of like relabeling. Overwrite that. And then I'm just going to reflash this existing chip. I'm using the term reflash very loosely here. Done, update. Cool. And I still ran it to the wrong location, but that's okay. And this f of x function will automatically invert the forwards and backwards direction for me. At least it should. We'll see. Okay. It did. Cool. Oh, let's dark out. Let's fix that. Okay, and there we go. Now we have a tank steering system that is just a 1 by 2 by 1 cube. Maybe. And I guess that sums up the tank steering tutorial. If you stuck around this long, thank you for your time. I hope that the tank steering module logic comes in handy. It will be getting posted to my workshop creations very momentarily. And use it however you like. I'm very much a huge supporter of open source. If you wish to give credit behind the microcontroller, go for it. I'm not a huge stickler on it. I also have a map HUD there. Check it out. I'll be making a video on that at some point in the future. Anyways, goodbye. Thank you.